Hello, lovely humans. Today we're going to talk about the unit circle, and hopefully you remembered your special right triangles last week because the unit circle is completely built using special right triangles. So what the unit circle is just a special circle that has a radius of 1. So what does that mean? Well, if we start here at the center of our circle and we go all the way out to the edge, that is going to be a measurement of 1. So we'd go over 1, up 0 to find the ordered pair of this point right here. So that is a point 1, 0. So if we think about it, then if we're going to go up here, actually, let's not use that. Let's just do a different color here. If we were going to go straight up here, this is going to be over 0, so we're not going to the left at all. Our x value is 0 there, and then we're rising 1. Okay, so then we're going to go to the left over here. If we went left, we would go -1, right, and 0. And then if we go down, we're going to go 0 left and right, but we're going to go down -1. So that's kind of the basics of what we're doing here with this circle. So we have a radius of 1, and then we're going to use special right triangles to figure out the rest of these ordered pairs. These circles are going to be for your degree measurement, and the squares here are going to be for a radians measurement. So what does that mean? Well, degrees are the way that we have measured angles thus far in math, but radians are another way to measure parts of circles, or another way to talk about a portion of a circle, for example. So it's built off of the idea of circumference. So if we know that circumference equals 2 pi times the radius, then the circumference of our unit circle is going to be 2 pi times 1, which is just 2 pi. So when we come all the way around this entire circle, so if we start here and we go all the way around, we have traveled a distance of 2 pi, and that would be our radian measurement. Also known, though, if we were at the starting place, so if we were starting here, this would be 0 radians. We haven't gone anywhere yet. This would also be 0 degrees. We haven't gone anywhere yet. However, if we had gone all the way around the circle, this is going to be 360 degrees. Okay, so 360 degrees must be equal to 2 pi in radians. So we know that 360 degrees is equal to 2 times pi. So if I wanted to solve for, to figure out how I'm converting between these two, I need to figure out what I would multiply 360 by in order to get to that 2 pi. So the conversion ends up being, we take our degrees and we multiply by 180 over, oops, I did that backward, excuse me. We take our degrees and we multiply by pi over 180, and that will get us to our answer. So if you take 360 degrees and you multiply by pi over 180, you're going to get to 2 pi, because 360 divided by 180 is 2, and the pi is just left over. So that is our conversion. This will equal your radians measurement. So you take your degrees, this is your degrees, you multiply by pi over 180, and that will give you your radians measurement. Okay, so that's how we're going to get all the radians on these things. And then to find our coordinates, we're going to build this off of our special right triangles. So if I were thinking about this point right here on the unit circle, and I wanted to find the ordered pair that represents it, I can draw a right triangle right here, and this would be 30 degrees. So if you think about how this unit circle has been broken up, that's 30, this is going to be 15, 15, and then this is a 30. So the big gaps are 30 degrees, and the smaller ones in between right here are going to be 15 apart. So these are 15 apart, 15, 30, 30, 30, 15, 15, 30. And that's how this unit circle is going to build. So we start at 0 degrees, we go up by 30, and now we have 30 degrees here. This is a 30-degree angle. Okay, so in my special right triangles we talked about up here, if we have a hypotenuse of 1, right? So this is the triangle we're looking at. This triangle fits right there in the unit circle. Whoop, look at that. So that is what we're using. So this is just a 30, 60, 90 built into our unit circle. Okay, so we have a hypotenuse of 1. We know the radius of this circle is 1. And we know that when we did special right triangles last week, if the hypotenuse is 1, we end up with a short leg of 1/2, right? Using our special right triangle rules. And we end up with a long leg of square root 3/2. If you don't remember where those came from, go back to that video on special right triangles from last week. Okay, now this is the same exact triangle here. It's just the sides have been flipped a little bit so that we can see it more clearly in our unit circle. So that's how we get those measurements. If you recall from your 45, 45, 90, those legs are the same, excuse me, and they end up being square root 2 over the square root of 2, and they are both square root 2/2. All right, so what we just decided, we have this triangle here. We're going to take and stick it right there. Oh, look, there are my measurements. It's going to be a little hard to see, but basically this 1/2 right here is now going to be right here. So that's my height measurement, right? That's my height measurement, my Y value. So this is going to be 1/2. And then we have the distance, or the X value, my horizontal distance here, this way is going to be square root 3/2. So that's my X value. My horizontal measurement is my X value, square root 3/2. Okay, same idea. Same idea if we were to take this triangle, that would be our next one. That's our 45, right? And so this measurement is going to be square root 2/2, my horizontal distance right here, square root 2/2. And then my vertical distance is also going to be square root 2/2. Okay, so see how this is building? And then last but not least, oops, I keep thinking that I can just drag that. Try again. Last but not least, this guy is going to be right there. Ignore that I stole half of that 40, or the other 30, 60, 90. This is just a flipped 30, 60, 90 triangle. And now I'm only going over 1/2. I'm only going over 1/2, and I'm going up square root 3/2. One of the ways that I remember this is, remember the short leg of this triangle? The short leg is smaller, right? So if you think about it, this distance here is smaller than this distance here. That's how I keep track of which one is which. And that's the basics of how this entire thing is built. Now, as we go to the left, these angles are going to increase. So we start here at 90 degrees, right? This is a perfect right angle. So this is 90 degrees right here. Let's use green for that. So this is a 90 degree right here. And so as we move forward, these are going to be greater than 30, 60, or 45, but they're all built on that same premise. So what we've done here, we're taking our right triangles. Now we're drawing them backward, right? So what we're going to do is take, this is our green one, so we can do it this way. We're going to go our short distance, like that. We're going to draw our right triangle like that. So notice this one is just going to be, this is going to mirror this one. And then the only thing you really need to pay attention to is that we're going in the negative X direction. So remember, this way is going to be our negative X. So this will be negative 1/2, right? Negative the same distance as over here. And then we're going to go up positive square root 3/2. Square root 3/2. So that's how we're building this. And then again, we're just going to rotate all of these around this unit circle. So if we were to move down here, then our next one would be over here down to this one, right? There's our other 30, 60, 90. Again, we're drawing straight down. We want our right angle to be, right there. So we want our right angle to go down from our x-axis and connect to our unit circle. And then again, just to complete it up here. So notice those are all of my different 30, 60, 90 triangles drawn in there. We could do, not all of them, right? We also have the other version. So we also have our 30, 60, 90s where we're focusing on our 30-degree angle, right? And then we also have our 45-degree triangles that are living in here. So then we also have these. So notice every single one of these lines is based off of those special right triangles that we discussed. Oops, there we go. That we discussed last week. So that's why those are so important going forward. All of this can be derived based on special right triangles. Okay, so let's look at this unit circle completely filled out and just talk about some of these features. So again, I did my colors differently so we could kind of focus on just our X values here first. So remember, X is our horizontal distance here. So when we're talking horizontal distance, we're talking about a measurement of cosine, right? So we're going this way. This is going to be our adjacent. So if we think about our angle being right here, then our adjacent side is going to be our horizontal distance, also known as our cosine. So all of these are going to be cosine values. So if you go ahead and plug into your calculator the cosine of 60 degrees, you're going to get 1/2. If you plug in cosine or sine of 60 degrees, you're going to get square root 3/2 because our vertical distances here, are going to be sine measurements, right? So when we talk about our angle here, our 30 degrees, and we talk about sine, we talk about opposite over hypotenuse, right? Our opposite over our hypotenuse. So opposite is going to be a vertical measurement. So all of our y values are actually representing sine. So the sine of 30 degrees is 1/2. If we go over here, the sine of 150 degrees is going to be 1/2 as well. But down here, notice, now we're in the negative. All our values are negative. So the sine of 210 is going to be -1/2. Okay, so let's look at that. Positive, right? This is the first quadrant. So we know that all of our x, y values here are positive. So we have our positive x, positive y. As we go to the left, now we have negative x. We're still positive y though. Again, be thinking about these things in terms of cosine and sine as well. So we're talking about a cosine measurement here. Our vertical measurement is our horizontal measurement is a cosine measurement. And our vertical measurement is a sine measurement. So over here, cosine is going to be negative, but sine will remain positive. Okay, as we go around this unit circle, now we're going to be negative, right? And then over here, we are still in the positive x direction, but we're going in the negative y direction. So if you look at my ordered pairs as we move around this unit circle, all these ordered pairs are going to mirror what you think. Remember, what we're doing here is just looking at this circle as if this point right here were 0, 0 on the coordinate plane. Okay, so let's talk about degrees. We said that we're going to go, the big gaps are 30 degrees and the smaller ones are 15. So we go 30 plus 15 is 45. 45 plus 15 is 60. Now we have another 30 gap. 60 plus 30 gives us our 90. 90 plus 30 gives me 120 plus 15, 135 plus 15, 150, so on and so forth around this unit circle. Remember to convert from from degrees to radians. We're going to take our degrees and multiply by pi over 180. So right here, if we have traveled all the way around this entire unit circle, then we've gone 360 degrees, and that is equivalent to 2 pi. You can do the same exact thing to get all of these conversions. So to go from 30 to pi over 6, I would take 30, I would multiply by pi over 180, and when I simplify that down, I'm going to end up with pi over 6. And that's how we get all of these conversions here between our radians and degrees. We talked about where all these ordered pairs come from. Again, that's built on our special right triangles. And then you really just have to pay attention to your signs, positive or negative. Okay, another thing I want to point out. Notice that square root 3 over 2 and 1/2 are always buddies. So even up here, they switch spots, but they're still together. And square root 2 over 2 and square root 2 over 2 are always together as well. All right, so let's think about what all of this means. If we have a 30-degree angle, boop, so we're going to draw that something like that, right? There's my 30-degree angle. This is 30 degrees right here. And we want to figure out what these measurements are. Well, I know that sine is opposite over hypotenuse, and my opposite, that's my short leg, that's a measurement of 1/2, and my hypotenuse is always 1. So 1/2 divided by 1 is just 1/2. Okay, cosine is going to be my adjacent side. My adjacent side here is the long leg of my 30, 60, 90, so that's square root 3 over 2 divided by my hypotenuse, which is 1. So this is just square root 3 over 2. Slightly more complicated. Now we have tangent. Well, tangent is opposite over adjacent. So now I'm going to take my 1/2, my short leg measurement, 1/2, and divide by square root 3 over 2. So I'm going to take 1/2 and divide by the square root 3 over 2. Okay, now you have a fraction divided by a fraction. That's a little intimidating to look at. I prefer to write it like this. Then we remember the rules for dividing with fractions. We invert and multiply. So we end up with 1/2 times, let's not do that. Let's do 1/2 times square root 3 over 2. We're going to multiply across the top, square root 3, multiply across, oops, hello, get it together, Fennell. That was not giving me the answer I expected to see, which is how I caught my mistake. When we invert and multiply, you must invert. 2 over square root 3. There we go, that looks better. Now my 2's cancel out, and I end up with 1 over the square root of 3. But at that point, your brain should be saying, oh no, not allowed to have a radical in the denominator. So we multiply by 1, square root 3 over square root 3, and we cancel out our radical in the denominator. We end up with square root 3 over just plain old 3. So tangent is going to be square root 3 over 3. Okay, you can do that for the 45 and the 60, but let's look at the 210 together because we haven't specifically talked about that. Okay, 210 is going to be like this, right here, approximately 210 degrees. This is also a 30, 60, 90. This reference angle here is 30 degrees. So to get from my x-axis down to this 210, it's a 30-degree move. So this is going to be based on a 30, 60, 90 triangle. And now I just need to pay attention to negatives and positives. So again, sine, we're going to be talking about this distance here, this vertical distance, and it's negative because we're going down. So this is going to be negative 1/2 over 1, or just negative 1/2. Cosine is also in the negative direction. My adjacent measurement here is also negative, square root 3 over 2 divided by 1, again, just negative root 3 over 2. Tangent. Okay, well now I have a negative divided by a negative, right? We have a negative direction here and a negative direction here. My opposite and my adjacent are both going to be negatives, so I'm going to end up with a positive, and it's just going to be the same as it was here. So this is just going to be positive square root 3 over 3. All right. Let's look at this and what this thing means. So what are these ratios? Are they positive or negative? Let's draw a right triangle and check it out. So if we draw a right triangle in quadrant 2, right, we're just going to draw a right triangle in there. Again, if we're thinking about this in the unit circle, the hypotenuse would be 1. But let's just talk about our sine and our cosine. Okay, in quadrant 2, I'm going in the negative x direction. And remember that x is the horizontal measurement here is a measure of cosine. So cosine is going to have a negative value here. Sine, however, is a vertical measurement. We're going up here. So the sine is going to be positive, and the hypotenuse is positive. So positive, positive, giving me a positive relationship here. However, cosine is going to be a negative divided by a positive, and that's going to give me a negative. So cosine is going to be negative in the second quadrant. And tangent is going to be a negative divided by a positive, so it's also going to be negative. Again, tangent is opposite a positive value, over adjacent, in this case a negative value, a positive divided by a negative is a negative. All right, you guys try and fill out the last bits of this and let us know if you have questions. Hope you're doing well. Miss you all.